And today we'll be working on one of the IMO problem, which is asking us to prove that this equation is irreducible for every number n. So to do this, here's the following thing that we can do. We can first separate it into two parts, which is 14n plus 3 plus 7n plus 1 is equal to 14n plus 3, which is equivalent to 14n plus 3 divided by 14n plus 3, right? And then it's plus 7n plus 1 is 14n plus 3. So in this case, you have the same, right? And for the 7n plus 1 divided by 14n plus 3, you could further split it into two parts. I mean, you could further split it. Just give me a second. It should be 7n plus 1. You could split the denominator into 7n plus 1 plus 7n plus 1 plus 1. So in this case, you will be able to get, you could able to see that its denominator part, this part is not reducible because it's a plus 1, there's a plus 1 here, and this is 1 over 2. Like this 1 7n plus 1 and 7 plus 1 plus 7n plus 1, which is clearly irreducible. Hence, we can see that this statement is true. I mean, it's true, which means that 21n plus 4 divided by 14n plus 3 is irreducible for every number n. Now let's look at another possible approaches. So it's still the same problem, except we are going to do it in a similar approach. So for this problem, we could also separate it in the following form, which is 20n, 14n plus 3, 1.5, 21n plus 4, minus 0.5. Oh, sorry, it should be 14n plus 3. I'm so sorry. 0.5 divided by 14n plus 3. So in this case, you will be able to get 1.5 minus 0.5 14n plus 3. Yeah. And then it's evident to see that for this part it's equal to 1 divided by 28n plus 6. So this means that you can see for this part of the fraction, it is irreducible regardless of the value of n. Or you could also test it by like actually manually doing it. Just give me a second. So it's equal to 3 over 2 minus 1 divided by 28 and plus 6. So you could do the following. You could okay, never mind. So in this case, this one is sufficient to show that 21 plus 4 divided by 14 plus 3 is irreducible for every n. We could also do another way, which is proof by a contradiction. We assume that this one is irreducible. 14n plus 3 is irreducible, which assume that it is reducible. Is reducible, which we set m as most common divisor. So in this case, it's going to be, so we can set up the following things, which is 20n plus 4 mod is equal to this, mod m. Or you could set it as the following, which is 14n plus 3, 0, mod m as well. And then you multiply equation 2 by a factor of 3 and multiply equation 1 by a factor of 2. You're able to get the following. Mod 0, which is equivalent to mod m. And then it's, just give me a second. And then what you can do here is that for this part, you multiply it by 3, which is this thing is mod 0. So in this case, this one generates a mod m as well. And you subtract 3 from 4, which in this case you will get 1 is 1 mod 1 0 mod, mod m, which clearly does not make sense. Hence, the statement is false, the assumption is false, which means that we can set m as the most common divisor. Sorry, which means that this thing is irreducible. Here we come to the end of our lesson, and I hope you have learned a lot. See you next week. Bye bye.